Maria Jose Lozan, and I will be solving 4 problems for the video assignment number 1 for Math 2000. So the first problem says that you need to state the chain rule. So in order to, for the chain rule to occur, there must be certain conditions that must be followed. So if f is differentiable at GA and GA and G is differentiable at A, then f G of A is differentiable at A, and therefore f f of G of A, and you take the derivative of this would equal the derivative of f of G of A times the derivative of G of A, which is the chain rule. So the second problem says you need to derive a formula for the derivative of arc tan of x using the rule of the inverse function. So the rule of inverse function says that if you want to derive the inverse function, then this equals to 1 over f prime of the inverse function of f of x. So in order to find the derivative of arc tan of x, we need to use the inverse function. So in this case, this would be what the inverse function value. So the normal function would be tan of x. So if we apply this to this equation, we would get 1 over second square, as it is the derivative of tan of x brackets arc tan of x. So we'll define this. And so in order to make this simpler, we can use one of the trigonometric rules, which states that second squared of x equals tan squared of x plus 1. Therefore, this will equal 1 over tan squared of arc tan plus 1. And because this is an inverse function of this, the property states that this would end up as x squared plus 1. And now we know that the derivative of arctan of x equals this. So for number 3, we need to derive a formula for the derivative of a composition of 3 functions. And so in this case, we if we want to find it, we need to write the 3 functions, which would be f of g of h of x. And if we derive this, we would get f prime of g of h of x times g prime of h of x times the derivative of h of x, which is what they're asking us to define. And finally, the 4th question is find the derivative of arctan of e to the power of tan of x. So we remember that so f of x equals arctan of x, then g of x equals e to the x, and h of x equals tan of x. So the derivatives of these functions would be, the derivative of f of x would be, as we saw, 1 over x squared plus 1. The derivative of g of x would be e to the power of x, and the derivative of h would be secant squared. So we need to insert these values in this equation. So we would have the derivative of arc tan of e of x of e of tan of x with respect to d of x equal 1 over e to the power of tan of x squared plus 1 times e to the power of tan of x times secant squared. And then when we multiply this, we get e tan of x secant squared of x over e to tangent of x, because this multiplies with this, so you get 2 on the front of